Uh, Hello student, Lami's theorem, lecture 3. Previous class we have already discussed the what is the Lami's theorem, and after that we have already proved the Lami's theorem and also solved the simple numerical problems. Today we will also solve the simple numerical problem by applying the Lami's theorem. Let's see how solve how can solve the Lami's theorem simple problem by applying the Lami's theorem. Let's see. Here we can see that a string ABCD and attached to the fixed point A and D has two equal weight. A and C has two equal weight and 1000 Newton attached to it at B and C. The weight rests with the portions AB and CD inclined at an angle shown in figure below. Find the tensions in the portion AB, BC, AB, BC and the CD of the string. If the inclinations of the forces BC with the vertical is 120 degree. Let's see how can I find out the tension AB, BC and CD of the string. Let's see. First of all, we see here if a string ABCD attached to the fixed point and has to be if ABC it is split into the two parts. Let's see this like if string ABCD and ABCD in the previous slide we can see that ABCD there and is attachment we can break into the two part like ABC and your here the load at B and load at C is equal to 1000 load at B and load at C is equal to 1000 Newton. See the previous slide, and same loaded at point B and point C. Now for your sake of convenience, the split into the string ABC in the two parts. The system of the force at a point B is shown in figures. Here we can see that the string, the tensions at AB, tension at AB and tension at BC is equal to how much you can find out by Lami's theorem. Now first of all we find out the angle between the is the three force acting at a point by applying the Lami's theorem at point B. The what is the angle between the and the tensions AB and the loaded angle in the loaded 1000 kilonewton load at point B. This angle is how much, and the angle find out between the angle the tension BC and the loaded angles 1000 kilonewton load is downward direction is angle. This angle is how much, and also find out the angle between the tension BC and the tension of AB. This angle is equal to how much. First of all find out, and after that we are applying the Lami's theorem. Then we find out that then we can easily find out the tension of the AB and the tension of the BC. Now here we can see that the slides this slide you can easily see that the angle this slide we can easily find out the three angle easily by applying the geometrical concept. The middle point where is the middle point is the point is B, and the AB and the and the load 1000 kilonewton is downward directions. The angle is how much? The angle is how much? This angle is equal to 180 degree minus this angle is equal to 30 degree. That means this angle is equal to how much? 180 minus 30, then is equal to 150 degree angle. Same manner, the middle point B and the force C and downward directions the loaded is 1000 kilonewtons. The angle is equal to how much? The angle between this angle is equal to this angle is 120, and this is straight line, that means 180 degree. Then 180 degree minus 120 is equal to how much? Is equal to 60 degree. So therefore this tension for this uh, tension for BC, BC and AC, and the loaded 1000 kilonewtons. the this angle, that means tension BC and the load downward directions 1000 kilonewtons. This angle between this is equal to how much, is equal to 60, and this angle tension AC and the 1000 kilonewton is how much, 150, and angle tension AC and tension BC is equal to how much, is equal to 120 plus 30 means 150-degree angle. This manner is we can easily find out the different angle by applying the simple geometrical concept. They can easily find out the different angle. After that, we are applying the Lami's theorem at point B. By applying the Lami's theorem at point B, here you can see that the figure, the tension TAB by opposite angle is equal to how much? Opposite force tension BC and the loaded angle is how much angle? 60 degree. That means sine 60. Then angle we can write here TBC, which means tension BC is equal to this force. Then angle between other two forces is equal to 150. Then means TBC by sine 150. Then equal to loaded is equal to 1000 newtons downward. Then angle between the other two forces is equal to how much, 120 plus 130, 120 plus 30 means 150. Then solve the any two equation that we can get the TAB and the TNBC. And here we can see that TAB is equal to how much, we can cross multiplications, then 1000 into sine 60 by sine 30, then putting the value of sine 6000 into sine 60 is equal to how much, 0.86, sine 30 means 0.5, then simple calculate the find the value of tension AB is equal to 1732 kilonewtons, and again putting the value of same manner, and tension is BC is equal to 1000 into sine 30 by sine 30 is equal to 1000 newtons. This way you can easily find out the different um, we can different forces by applying the Lami's theorem. Then this is the first portion. Then another portion I can find out same manner, we can find out uh, the another portions by applying the Lami's theorem. Let's see. Here you can see that it is another portions. Then the tension BC and the tension CD, the angle already find out the 60 degree and the 60 degree. Then 1000 kilonewtons downwards, and the angle between tension at BC and the 1000 kilonewtons is equal to how much, is equal to 120. Then how much angle between the CD and the 1000 load kilonewtons downward is equal to how much? Then this you can easily find out the it is a total angle is equal to 360. Then 120 60 plus 120, then means 360 minus 120 plus 120 means 240 is equal to 120. Then again the angle between the CD and the 1000 kilonewton downward direction is equal to how much, is equal to 120. After that, applying the Lami's theorem at point C and find out the value of the tension in CD. Let's see. And here we can see that we have already find out all the angle between the BC and loaded 1000 kN downwards, CD and loaded 1000 kN downwards. After that, applying the Lami's theorem, according to the Lami's theorem at point C, TBC by opposite angle between the two forces, that means already we can see that the sine 120. Then tension CD is equal to how much, tension CD is equal to C and D, and opposite angle between this is equal to also 120. Then 1000 kilonewtons, and opposite angle between the BC and CD is equal to how much, 60 plus 60 is equal to 120. That means 120. All the angle as 120 you can see, and we can easily find out you can easily find solve this geometricals by applying simple geometrical. After that, applying simple multiplications, and CD is equal to how much, we can already see that the you can already cancel the sine 120 sine 120 already cancel out. Then tension CD is equal to how much, tension CD is equal to 1000 kilonewtons. Then this way, or this manner, we can easily solve the simple problem by applying the Lami's theorem. And so it is a simple problem solved by applying the Lami's theorem. And next lecture we can see more problems in this in this type of in this type of next lecture we can see the more problem applying the Lami's theorem. So it is very important chapter by applying the Lami's theorem. So thank you.